It was July 7th, 1919, and a convoy of U.S. Army trucks set out from Washington, D.C. en route to Oakland, California. Their journey was arduous, to say the least. There were 230 stops due to difficult roads, accidents, and mishaps. The roads were at times non-existent, with practically all roads unpaved from Illinois to Nevada. Along the way, the convoy broke and then repaired 88 wooden bridges. Altogether, the convoy logged 3,250 miles with an average speed of 5.6 miles per hour. It was a tough journey. One of the members of the convoy was a young officer by the name of Dwight D. Eisenhower. It was quite simply an experience he would never forget. And later, as President of the United States, he would call for the creation of a national interstate highway system. Initial construction was authorized in 1956, and the original sections were completed 35 years later. At the same time, in Canada, the construction of the Trans-Canada Highway was underway, linking together for the first time all 10 provinces. In the decades that followed, the roadway systems in North America continued to grow, linking together communities far and wide. The impact of these roadways has been enormous, reducing accidents and saving lives, serving as the foundation for economic growth as goods and services are readily transported to their intended markets, improving productivity, increasing international competitiveness, bolstering national security, and enhancing quality of life. Yet, there is a dilemma. In many cases, these roadways are aging, and the need for ongoing repair and maintenance are outpacing the funding required. In the United States, the Federal Highway Administration estimates that nearly a quarter of the nation's 600,000 bridges are structurally deficient or functionally obsolete. And repairs, when they are made, are often disruptive, slowing the shipment of goods and causing inconvenience for communities and travelers. These delays have real costs. According to the shipper UPS, if each of its 95,000 vehicles is delayed an average of 5 minutes a day over the course of a year, it costs the company $103 million in added fuel costs, wages, and lost productivity. Clearly, there's a need for new solutions to help keep roadways operational and productive. Today, precast concrete products are helping provide solutions for roadway projects across North America, as well as a wide range of other transportation-related applications, such as products for pedestrian walkways and bridges, for aviation, for rail, and docks, platforms, and seawalls, and underground applications. And there are a number of reasons that precast products are chosen. Easy installation. Precast products arrive at the job site ready to install, often saving weeks over traditional cast-in-place construction. Increased strength. The strength of precast concrete increases over time. And less ongoing maintenance, often providing service life in excess of 100 years. A wide range of products are used in road and highway construction. Let's take a look at some of the precast concrete solutions currently in use for roadway construction and maintenance. Precast concrete pavement slabs can be used on highways, intersections, exit ramps, and airport pavement replacement for long-lasting, speedy surface repair or new construction. Precast concrete pavement slabs are prefabricated off-site in factory-controlled conditions and delivered to the job site fully cured and ready to be installed for immediate use.
Initially, it was difficult to go in and talk to these DOTs and say, we really need to do something about this. How we did it was we found a project that had a rapid set concrete, some type of quick setting concrete spec'd. And we went in and said, you know what we can do? We can do this in precast concrete. So instead of a 5-year life cycle, 7-year life cycle, we're going to give you a 40-year life cycle on your repair. And that got the attention of the DOT. And they initially said, well, we'll try a single project and just see how it goes. And it went so well that led to another project and another project and another project. And they're finding new uses for it now.
Precast concrete pavement has a huge potential for speeding up and reducing the risk of overnight construction and getting the freeway returned to the public without them even knowing that anything happened, except all of a sudden now the roadway is easier to drive on, and it stays that way for years.
Using a fully cured concrete system results in greatly accelerated construction scheduling and sequencing, reducing risk to road workers and the traveling public, all without jeopardizing the surface quality, durability, and long-term performance of the roadway.
The speed and efficiency of a jointed precast pavement system is actually the primary driver in the way that we've used that. We like to close the road for as short amount of time as possible and get it open to traffic. We want to do all of our work off peak. Precast pavement systems is really the only way that we're able to stay within the kinds of windows that we want to have and still expect some durability for the repair. So that's been the primary reason that we've done that.
Precast concrete pavement systems provide long-term solutions due to precast concrete's ability to withstand heavy traffic flow over many years.
Our very first project was a pour-in-place project that we converted to precast. So we had the big orange cones along the freeway for several months, but it happened in the middle of the night. We actually had people calling our DOT and complaining because there was no work being done and all the traffic control was set up. So the DOT had to explain that, no, it's happening in the middle of the night. And the public was so excited to see the changes. I mean, they were getting phone calls about it. The freeway was getting repaired, the potholes were disappearing, and it had absolutely no impact on the traffic.
Jointed precast concrete pavement is made up of individual slabs that are 16 feet or less. The vast majority of concrete pavement in existence today is jointed. Jointed precast slabs installed in an existing jointed concrete pavement structure retain the expansion and contraction characteristics of the surrounding existing pavement, making it the logical choice of repair for existing jointed pavements. Jointed precast concrete pavement can be designed for a wide range of applications such as horizontal curves, three-dimensional surfaces, widening, changing crown lines, utility-intensive pavement, instrumented applications, and heavily skewed bridge approach slabs. Jointed slabs may be used singularly for isolated repairs or in multiples to create a continuous surface of new pavement. Computer-aided survey, forming, and grading equipment makes it possible to replace three-dimensional pavement encountered in intersections and super elevations.
So precast concrete is a superior product to cast in place because it's not weather dependent. We make the slabs in a controlled environment off-site any time of the year, and these slabs can go in January in Utah in the mountains. Precast concrete pavement has a safety implication. The actual people who are working on the job, they have a lot less exposure to being on the highway in the middle of the night than they would in conventional construction, because a lot of that risk is taken in our yard, which is in a safer environment. We're not dodging cars, and then they go out and they do it on the job site, and it goes in really quickly. So it's a safer installation.
The advantages for motorists, I think, is the potential invisibility of the project. Our first project, I knew we had kind of met our goal of being able to mitigate the impacts when I had a couple of neighbors ask me, hey, when are you going to start that project? We've had the barrels up along the side of the road for months now, and we haven't seen anything happen. At that time, the project was nearly complete, and it was just going on at night, wasn't impacting anybody, and people wouldn't notice it during the day until you point it out, and then they could tell where the repairs were.
The jointed reinforced concrete pavement precast panels definitely is an efficient way to replace concrete roads in high volume traffic areas. It is an expeditious way of repairing the roadway, especially again in areas where you do not have access to full closures of the roadway or traffic redirection. And again, it's an expeditious way of getting a complete replacement versus just a patch or an overlay, per se.
Precast concrete short span bridges can provide an attractive solution for many transportation needs. Whether it's replacing an aging deficient bridge or developing new roadways. Designs include attractive single-piece arch, functional two-piece arch, and conventionally reinforced flat bridge, parapets, wing walls, head walls, and end walls. Each system has its own specification for span length, span height, and load capacity. Precast concrete short span bridges can also include spandrel and wing wall panels with architectural finishes. Finishes commonly available are colored smooth as cast, textured form liner, exposed aggregate, acid etch, brick, and sandblast. Each is distinctly different and provides architects and owners a broad choice in appearance to help match the surrounding environment.
Precast bridge systems, to me, are the way to go for small span bridge replacements. If you have bridges within your community that's structurally deficient or functionally obsolete, then you definitely should consider either a box culvert or a three-sided bridge, or even the arch bridges that are available in today's market. We look at cast-in-place projects quite often. We think there's many advantages for precast in those areas. There's one project in particular where they were going to cast in place a tunnel structure. So we talked to the apparent low bidder on that structure and proposed using a box culvert with sloped end sections. And when he looked at the proposal, he said, well, I think my price is pretty close to yours. However, in looking at what you offer, I can have this done much quicker. So he went back and talked to the city, and he was able to get the precast box culvert system approved. And we supplied, I think it was about 60 linear feet of box culvert for the structural elements, and then the sloped end sections, in essence, became the wing walls.
St. Lawrence County, New York, is a community that has decided that precast is a significant part of the solution in maintaining key bridges. The county has been a leader in building bridges using geosynthetic reinforced soil integrated bridge system, or GRS-IBS technology, rather than conventional bridge support technology. GRS-IBS technology uses alternating layers of compacted granular fill material and fabric sheets of geotextile reinforcement to provide support for the bridge. The technology offers unique advantages in the construction of small bridges in conjunction with precast concrete components.
We've used precast concrete for several applications. Most recently, our applications, majority of our applications have been precast box beams for our GRS bridges. We've also used a lot of precast box culverts and catch basins for our drainage structures and our road crossings.
St. Lawrence County selected a bridge originally constructed in 1932 for renovation with precast design. The bridge was sorely in need of replacement, with 2 New York State Department of Transportation inspection flags, one being a safety PIA flag. All in all, St. Lawrence County was delighted with the speed and cost effectiveness of their initial precast bridge replacement project. They estimate that approximately 50% of their bridges in need of replacement can be done with precast.
We choose precast concrete products over alternative materials in general due to the immediate need We can put it in place, not have to worry about cure times. It's built according to our specifications. Sizes are correct. We can just build our pads, especially for our road box culverts, and put them in place. Manholes are the same. You know exactly what you're getting. The proper opening sizes and the seals and whatnot that all come along with those. Our pre-stressed box beams are a time saver for us. We don't need cure times in the field, so it's one less step in the process when you're constructing bridges. We don't need to worry about 14 days of cure time on a deck where we can't get on it, we can't open it to traffic. It really shortens our construction duration.
When it comes to overpasses, precast concrete can span everything from gullies to gorges, including comprehensive solutions that can traverse major rivers. Precast concrete bridge replacement systems installed during off-peak travel times are revolutionizing the way overpasses are repaired. User surveys cite congestion and traffic delays due to overpass construction as a major source of frustration for motorists. Traffic congestion also reduces highway capacity and increases the costs associated with delays for the traveling public. Precast concrete beams and approach abutments assembled on-site when traffic volume is low reduce traffic congestion and offer many other advantages over traditional cast-in-place construction in high-density urban areas.
We have been working with the DOT and trying to get them to come up with a better product in the finished product. We had also had a meeting with all the DOT engineers about a year and a half ago, and we were trying to encourage them to and it's actually a question that I brought up. Precast bridges, for instance, they're putting out a lot of these express design builds, which are small bridges crossing maybe streams or single lane highways and whatnot, and trying to encourage them to utilize more precast to kind of excel these projects so that they don't have to impact the traveling public for this long duration of time it takes to cast a bridge in place or excavate and remove a box culvert and have the traffic diverted for long periods of time. And the DOT is very, very excited about getting involved more with precast and seeing more of the options and the benefits that are really there, that are real, that they can use to kind of incorporate into these express design builds.
Precast concrete bridge replacement systems also make the construction process safer and more efficient because road work can be completed overnight, on weekends, and during off-peak hours, reducing the need for roadway closures. Precast concrete bridge replacement systems also make the construction process safer and more efficient because road work can be completed overnight, on weekends, and during off-peak hours, reducing the need for roadway closures. Jointed precast concrete pavement can be used as a supplement to precast concrete bridge replacement systems when reconstructing the bridge approach pavement. Jointed precast concrete pavement will transfer the loads across panels when installed. Damaged areas of pavements leading up to the bridge replacement system can be replaced with precast pavement, custom built to meet the thickness, cross slope, and layout requirements of individual project sites. Jointed precast concrete pavement can be used for single lane replacements or full width road construction. Precast concrete box culverts, pipe, manholes, catch basins, and inlets are used for conveyance of stormwater. Precast concrete three-sided culverts allow for natural stream beds to remain intact while providing for short-span bridge applications. Because precast box culverts are produced in a controlled environment, they'll exhibit high degrees of quality and uniformity. Box culverts are common products, and many manufacturers maintain an inventory of several sizes of box culverts ready to be delivered in short notice. Precast concrete manholes are used for many underground applications, such as storm and sanitary sewer access, lift stations, and utilities. A properly designed and installed precast concrete manhole system provides superior watertight performance compared with competing methods and materials. A typical precast concrete manhole can be installed 500 feet deep and more because lateral forces act equally around the periphery, which places the section in pure compression, the ideal state for concrete. Durable, impact-resistant precast concrete stormwater inlet boxes are specifically designed to carry even the heaviest inflows of stormwater away quickly and easily. Concrete pipe is instrumental in protecting precious groundwater by conveying wastewater and stormwater through complex underground infrastructure systems. Precast pipe is available in a huge variety of shapes and sizes. The flexibility and modularity of precast pipe make it possible to meet the needs of any project. Precast concrete catch basins can be customized to job requirements or in modular components. They may be used in traffic or parkway applications with either galvanized steel or cast iron grates. Precast concrete catch basins allow contractors to drop the structure in place, make the pipe connections, and continue on with the project. With growing traffic and expanding communities, road noise has become a real irritant for communities living along the nation's highways.
North Carolina, they're building a turnpike, toll roads, and they're going through subdivisions. And when they do this, the communities don't want to see the highway, and they don't want to hear it. So, and over the years, they've come up with these sound walls and different types of sound walls. There's just the metal sound walls, which have a very short lifespan, and wood sound walls even have a shorter. And on precast concrete sound walls, there's two types. There's a reflective sound wall, and then there's an absorption sound wall. Mainly we do in North Carolina because North Carolina hasn't gotten to the sound absorption type. Most is reflective walls, and they're quite tall in some cases, and they are the ones that stand up alongside the highway and kind of deflect the sound.
Precast concrete sound walls can be designed to blend in with a city's architecture and local topography, or even to capture a community's theme or identity. Reflective sound walls can reduce the perceived noise by as much as half, while absorptive treatments have been found to further reduce noise pollution.
I think that the sound absorptive sound wall, it all depends on if there's neighborhoods on each side of the highway. Typically, they don't want the sound traveling back across the highway, back towards the homes, which a reflective wall would do. And we're seeing the use of sound absorptive walls more and more as they're expanding the interstate in our area, getting closer to the homes on the other side.
And with color additives or stains and textured form liners, the appearance options are nearly endless.
That we can achieve pretty much any look that they need. So if they had an area that they were trying to blend in because they had an historical structure or a building with a certain exterior finish that they wanted, or an old stone wall that was existing, we would look to match that. And there's a wide array of form liner patterns out there, and a bunch of companies willing to even design custom liners to fit those sites. And the forms that we design as well can take form liners, any form liner. We can implement a new pattern very, very quickly.
Concrete sound walls account for nearly half of all noise reduction walls constructed in North America. Precast concrete highway barriers provide important barricades against unwanted traffic, also serving as important safety and security devices to reduce the risk of an out-of-control vehicle crossing the median and colliding with opposing traffic or roadway workers. When installed parallel to roadways, precast concrete barriers have the unique ability to not only control traffic flow, but also reduce the speed of the vehicles. They're designed for safety. Upon impact, precast concrete barriers partially lift the stray vehicle off the pavement, which decreases the lateral resistance force between tires and pavement. Once this force is minimized, the barriers can effectively realign and slow the stray vehicle. Precast barriers can be installed in permanent or temporary applications. There are a wide variety of precast concrete earth retaining systems designed to provide a straightforward and cost-effective solution for transportation projects.
Retaining walls are various different types. You have a standard MSC retaining wall, which is has reinforcing straps or reinforcing tiebacks, or you have a retaining wall, a gravity wall style retaining wall, which is based on just volume, weight, and no tiebacks, but they have limitations on how high they can go.
Issues with wall height, right-of-way, seismic activity, and drainage can all be overcome by specifying the use of a precast concrete earth retaining system.
When it comes to economizing a job with precast over different products, one of the big things, of course, is time on the site, and the fact that not just with retaining wall, but with any precast product, we can have the job sitting in our yard waiting on the project versus if you're on site working, you have to do it as you go. So the many products, it's very good to be able to do them out of precast. With retaining walls in particular, the bigger the block, the faster it goes in. So if you're doing a comparison of, let's just say, going with small block versus big block, you're going to set 6 large keystones by hand, or you're going to swing a track hole one time. Well, when you've got a very big wall, the time savings and the labor, it's huge. And the other thing, in this day of accidents and L&I claims and everything else, the less labor you have on the site, the better. And also the less that they're having to lift and move, the better.
There are numerous systems available, including precast concrete mechanically stabilized earth panels. MSE walls are classified as gravity retaining walls that are designed to withstand lateral earth and water pressures and any live and dead load surcharges. Mechanically stabilized earth walls are built from individual panel sections. Mechanically stabilized earth systems have interlocking panels and are supported by steel straps that are mechanically attached to the back of the panel and extend back from the panel into the retained soil, resulting in a reinforcing zone behind the wall. The reinforced soil's mass, along with the facing, acts as an improved gravity wall. Large precast modular blocks. The site is prepared by excavating and adding a crushed stone leveling pad and drainage pipe. The first block is then installed on top of the crushed stone, and the area behind the block is backfilled. The process is repeated until the specified height is reached. Precast concrete products used in road construction are also widely used for pedestrian applications. Short span bridges, box culverts, retaining walls, sound walls are all frequently incorporated into walking and biking trails. Precast concrete products also play an important role in marine transportation. Floating docks, underwater infrastructure, decking, railings are among the uses of precast along the waterfront. Precast products can counteract the buoyant forces of water significantly better than most materials. Corrosion inhibitors can be added to the design to ensure a long service life. Products include bulkheads, marine boat launch ramps, marine pilings, pontoons, breakwater elements, and a host of others. Precast concrete products also provide the optimal solutions for many rail applications, including precast products designed specifically to minimize downtime with quick installation for railroad crossings, and highly durable and resistant precast railroad ties that minimize disposal and environmental hazards associated with traditional ties. Mariachi Plaza in East Los Angeles uses precast panels to replicate Mexican cantera stone and create a striking plaza for the California rail system. The centerpiece of the plaza is a gazebo created with Mexican cantera stone that had been donated by the city of Guadalajara 30 years earlier. In the renovation of the plaza, precast panels that closely approximate the color, texture, and shape of the donated cantera stone were created to complete the plaza.
The Mariachi Plaza is in the East LA, and it's a big part of the civic identity out there. It's a cultural hub, it's a gathering place, and central to that hub is a cantera stone gazebo that was donated by the city of Guadalajara about 30 years ago. When they decided to build the subway station in the same plaza, they wanted the canopies that protected the escalators down to the subway platform. They wanted it to blend in seamlessly with the existing gazebo. It was probably impossible to source cantera stone from the same quarry. Even if you're able to source cantera stone from that quarry, you're looking at material that's 30 years down the line, not to mention the gazebo itself has been weathered and has been developing a patina over the last 30 years as well. So whatever you pulled out would probably not match, even if you could find it. So what we did is we worked with the architect in the GC to create a custom panel made out of precast concrete, and we were able to match the color, we were able to match the texture. We put colored aggregate at the surface to replicate the unique nature of the cantera stone. So using a form liner, using different production techniques, we're able to create a custom panel that's lightweight, durable, and is going to match the existing gazebo.
Working with the project's architects and designers, the precaster was able to create a precast solution for Mariachi Plaza that enabled a shortened lead time with superior durability and at lower cost. In central Indiana, the US 31 corridor serves as a main conduit for travel to and from Indianapolis and northern suburban communities. Also located along this corridor are major hospitals and healthcare facilities, as well as prominent commercial, business, and industrial sites. The Indiana Department of Transportation, INDOT, undertook a project to transform this important artery from a 2-lane highway with multiple stoplights to a 3-lane highway with overpasses designed to both ease congestion and enhance safety. Altogether, the project consists of 12 interchanges and 14 miles of roadway.
This project actually, because it's in Hamilton County is one of the fastest growing counties in the nation, and Carmel and Westfield are one of the fastest growing cities in the nation as well. So due to the growth, the project had to be built quick, and at the same time, currently they're all signalized intersections. So the mayors of both Carmel and Westfield saw that those signals had to be removed, not only for safety reasons, but also because development has been sitting there anxiously waiting to develop these interchange areas. And until the interchanges moved in, the development wasn't happening. So the cities worked with INDOT to help make this project happen. And now all the developers are starting to see the project happening, and they're starting to make their moves to create jobs for the city of Carmel and Westfield.
From the onset, one of the challenges facing the project was the difficulties surrounding land acquisition to facilitate the roadway expansion. Precast concrete structures help designers minimize the project's land requirements.
Precast structures have been critical to this project just because of the land acquisition has also been huge, millions and millions of dollars. The acreage here in this area is about $1 million an acre. So it kind of tells you that you really can't buy a lot of land. So that's where we look to the precast concrete, the retaining walls, the three-sided type of structures to help us out to save money for NDOT. It allowed us to take less land, acquire less land, and then help out so the more businesses can remain and the tax base can remain for the cities of Carmel and Westfield.
The US 31 project makes extensive use of mechanically stabilized earth, MSE, walls. These walls are constructed of a specially designed precast panel facing and granular soils reinforced with linear reinforcement.
Mechanically stabilized earth, or MSE walls, are really a block of dirt with a concrete panel on the face. The concrete panel is the precast piece. You can see those behind me, and we have aesthetic treatments on these. Some of them are smooth, some of them have color, some of them have form liners on them. The part that's structural is behind that. It's a steel strap that sticks into the ground. Dirt is placed on top of those straps, and the friction between the strap and the dirt holds that block of dirt in place. Again, the concrete panels are the facing material. They're not the structural part. But without that part, dirt spills out and you don't have a road.
The installation of the precast MSE wall panels is fairly easy. The panels get shipped out here on a truck. We unload them with a loader. Then they're all numbered to the sequence following the pattern on the shop drawings. The guys go over there, find the number, pick it up with 2 hooks, are hooked into the top that are cast into the concrete panel. They bring it over, set it on the wall, clamp it off to another panel or to the ground, whichever one to support the panel, and then they backfill with sand or any kind of material that's suitable. While installing the straps, once they get to the top strap, they can release the clamps, and that wall is stabilized by the retaining straps.
Special care was taken to ensure that the MSE walls fit well within the surrounding communities.
The project also had a lot of visual aesthetics. City of Carmel, City of Westfield, very, very prominent areas in the north of Indianapolis. So aesthetics was key to this project. So we put a lot of aesthetic treatments on these precast structures, the MSE walls. We tried to mimic natural limestone, trying to make it fit. They call that context-sensitive solutions. It's a big thing with NDOT. It was a commitment on the project just to make the aesthetics of the whole project fit with the surrounding environment.
On this project, specifically the MSE walls, our landscape architect, Green 3, developed a kind of a stacked stone look. It's supposed to mimic closely a limestone, which is pretty prominent here in Indiana. And so it's all concrete, but it kind of looks like limestone. We worked pretty close with the precasters prior to the first construction project to make sure that something like this is possible. We've got pretty deep reveals on some of these walls, and that takes pretty particular care in the production process. So we wanted to make sure that we weren't overstepping our bounds with what we thought would look good, what we knew would look good. During the first construction project, the precasters provided example panels, test panels, and those test panels they look just like the ones you see behind me. It's worked out well. The lines are crisp. There's several different kinds of panels, and we see the same quality product on each one of them.
Having the precast concrete, it really blended well, as you can see in the background. It looks good, but you put a little more landscaping in front, it's going to blend really well with the whole surroundings of the whole area. So trees, shrubs, and having the precast structures took less right of way, so it gave us more room to put some plantings in there, which made the locals and all the businesses and the mayors very happy.
In addition to the MSE walls, precast concrete products played a vital role in the construction of many of the project's overpasses.
The US 31 project has over 50 bridges. There are several new interchanges being built, and every interchange has at least one bridge. There are several water crossings also. All but 9 of the structures on the project will be using concrete. Most of those are beam type structures, precast concrete beams. Most of them are bulb tees, some I-beams also. We have a new shape that we've worked with. Several design consultants have worked with precasters to develop more efficient concrete beam shapes, and we're utilizing those as much as possible on this project. The coordination with precasters is key on this project to determine what beams are available and what lengths. We have beams as short as 50 feet and as long as 150 feet. So to get those delivered to the project site, it's a pretty good project site. We're pretty well in the middle of the state. There's good access, but we still coordinate with the precasters to make sure that each of those beams are available.
The beams for each bridge were manufactured to exacting specifications.
Tolerances on the precast concrete beams is pretty specific. Obviously, we build the pier stems and the abutments prior to those coming, so they have to hit right where our bearings are on those within an inch. Precast did help on this project reaching our deadlines. The project is a 1-year job, $35 million. We had 2 ramp closures, one specifying 90-day maximum closure, the other one 80-day maximum closure. If we didn't have precast products like the MSE walls, the concrete bridge beams, if we had to wait for cure time, the rebar guides, the formwork, things like that, we would have never made those deadlines. And we did beat we're under one deadline now. We beat the 90-day deadline by 7 days.
The US 31 project also required a variety of precast drainage structures.
The underground drainage structures and products on this are all reinforced concrete precast, either pipe or drainage structures, box culverts. Typically, with using the reinforced concrete pipe, once we dig it out, we can lay the pipe in there and backfill. It's a more rapid backfill, allows us to get through it quicker versus a plastic pipe or something like that, where you have to pay a lot of strict attention to the backfill and make sure it's not compressing the pipe. The box culverts, they all slide together. They're a bell and spigot design, so you lay them just like a reinforced concrete pipe. You lube the ends and stick them together. And we tend to open cut everything and just throw them in one by one, just take them off the truck and put them right in. So there's nothing after that. We wrap the joints and then backfill them. As far as the drainage structures, they're all precast units. They come in about 4 foot tall. We've got drainage structures out here that are 30 foot tall, so they'll come in 4 foot segments, and then we'll stack them up as our fill goes up. We'll just keep stacking the pipe out.
Altogether, precast concrete products help designers and contractors meet the demanding challenges of the US 31 project.
The major advantages of these precast concrete products are cure time, forming. You use a lot more crew hours, equipment to set forms, rebar subs, things like that being involved. And you can make the product off-site and have it shipped in and set right away versus you having to build it and wait for things there. They can build everything off-site and bring it in and set it in one fell swoop. So I think time, cost, overruns on concrete, especially with we got to do box culverts, beams, things like that. The overrun on concrete, the contractor pays for. Precast concrete helps in the storage and the maintenance of the project because our suppliers, our precast suppliers, make it at their shop. They can make the 233,000 square feet of MSE wall, ship it out to us as we need it. We can keep our areas clean and free. We're working in a real constricted area on this project. So if we had to build it with all the formwork and all the rebar that it would take to build all these walls, all these bridges, we just wouldn't have the room to work. Overall, the quality of the precast concrete products used in this project specifically we've been very pleased with it. They go in, they fit, everything fits where it needs to be. The critical specs that they needed to meet all meet. We haven't really had any problems.
Precast concrete is an inherently sustainable construction material. On the US 31 project and NDOT project in general, there's not a requirement to meet any certain sustainability requirements. But on the use of precast structures, retaining walls, smaller 3-sided structures, instead of larger bridge crossings, we can attain a level of environmental sensitivity that can be considered sustainable use of public use projects.
This project had a lot of new innovative ideas that we've used. Thanks to the precast industry, they helped us to open our eyes really and see what actually is out there. The old technology of build that catch basin or precast structure by hand really isn't used as much anymore. Now it's you order the precast structure, you have it delivered to the site. Contractors like it, the owners like it, and the cities and the taxpayers seem to like it too.
Modern technology enables us to move concrete production from the field to a plant environment and greatly enhance quality control. Precast structures are manufactured in a controlled environment that enables careful control. Let's take a look at the typical manufacturing process. The production cycle begins with the initial setup of the forms prior to casting. If the product requires reinforcing steel, there are numerous ways to stage, set, and place the reinforcement. Reinforcement cages for the structure are typically assembled in a separate area using specifically designed machinery or pieced together by plant personnel. Machinery that is used to fabricate cages are able to cut and weld reinforcement wire to form the assembly required for the structure. Cages that are pieced together by hand are also an effective way to accurately position and stage reinforcement in the form prior to casting. Additional support for the structure can be provided by additional reinforcing steel, which is secured to the support structure according to the design drawings. This will further enhance the finished product's ability to withstand stresses in the field. Next, the reinforcing assembly is put in place according to the engineered detailed drawings. These reinforcing assemblies are made to exacting standards and must be carefully placed to maximize efficiency while providing enough concrete cover to protect it from the elements and to provide adequate bond. In the design process for the structure, engineers consider all loading conditions, including handling, shipping, installation, and service loads. Chairs, spacers, and other concrete accessories are used to keep the reinforcing structures in the correct position and prevent any shifting while the concrete is poured. A quality control technician carefully inspects the structure prior to closing the form, indicating it is ready to pour in many cases, to ensure that proper clearances for reinforcing steel are maintained and any embedded items or knockouts are accurately positioned. This quality control check is referred to as the pre-pour inspection and is one of many quality control procedures performed throughout the manufacturing process. The inner jackets and cores of the forms are typically coated with a form release agent, and then the cage assembly and/or reinforcing steel is placed in the form, paying close attention to avoid reinforcing steel touching coated surfaces. The batch plant operator would then start up the mixer to begin the batching process. Typically, batch plants are automated and are able to measure and dispense specific amounts of raw materials according to the designated mix designs. Once the batch of concrete has been mixed, it is placed into a bucket or other transport device, and the fresh concrete is transported to the form. The concrete is carefully deposited to avoid segregation and is consolidated into place with the use of vibratory equipment, unless SCC concrete is used. For conventional concrete, consolidation is a critical step in the process, as it is used to drive out entrapped air, which, if not removed, may increase porosity and decrease the strength of the concrete. Concrete testing is generally performed after the first batch of concrete is mixed, and throughout the batching process to ensure a uniform mix and one that meets the design requirements. One of the plastic concrete tests performed is a spread test. Spread tests are performed when using self-consolidating concrete, also known as SCC. Once the concrete has been placed in one lift in the inverted cone, the cone is lifted. The technician will then measure the distance or the spread of the concrete at 2 points perpendicular to each other, which will give an indication of proper viscosity and flowability. Conventional concrete has a similar test called a slump test. Other tests include temperature, unit weight or density, air content, and compressive strength specimen casting. After compressive strength cylinders have been cast, the specimens are placed in curing conditions similar to that of the product, so accurate measures of the next day, 7 and 28-day strength of the concrete can be taken. Concrete specimens can be tested at any day the project requires. Some cylinders are even placed in a water bath to provide 100% moisture for quality control laboratory testing. These cylinders will later be tested to measure the compressive strength of the concrete. Next day compressive strength tests are required to develop and define stripping strength of the concrete mix design. After the concrete has been completely deposited in the forms, the concrete begins to cure or gain strength. As the concrete cures, curing enclosures are sometimes used to help provide adequate moisture and temperature. Proper curing is essential in ensuring that the cement fully hydrates, maximizing hardened concrete's characteristics. Once minimum stripping strength is achieved, the products are stripped from the forms. After the concrete has met the next day minimum compressive strength, the product is stripped from the form and then the product is inspected. Products are inspected by the quality control technician to ensure they meet specifications and design drawings. After the quality control technician approves the product, it is marked, labeled, and moved to the storage area. This post-pour inspection is an important element of any precast plant's quality control program. Any product out of tolerance is marked accordingly and repaired. When it's time for delivery, products are loaded onto trucks and securely fastened to the bed. A quality control technician will then perform a final inspection to ensure that the proper products are being shipped, the products are properly loaded and secured to the truck, and that no damage has occurred during handling. The precast concrete products are then delivered to the job site for a speedy installation. For projects where heavy traffic limits the curing time, precast concrete solutions can play an important role. For example, precast pavement slabs require minimal, if any, additional on-site curing time since they are cast off-site, fully cured, and ready for use upon arrival. Plus, the durability of precast pavement is enhanced because it is fabricated in a controlled plant environment, free from adverse temperature and weather-related conditions. Precast concrete manufacturing plants stock a wide selection of admixtures and aggregates that may be used to optimize pavement life. The strength of precast concrete gradually increases over time and does not deteriorate when exposed to harsh environments, as some other materials do. Studies have shown that precast concrete products can provide a service life in excess of 100 years. Because precast concrete products are made in a controlled plant environment with advanced quality control processes, they exhibit high quality and uniformity. Problems affecting quality typically found on a job site, temperature, humidity, craftsmanship, and material quality, are nearly eliminated in a plant environment. And precast concrete minimizes problems associated with job site curing and shrinkage problems associated with conventional cast-in-place techniques. Plus, precast concrete can be placed in weather that is not conducive to cast-in-place construction, such as rainy, hot, or cold weather, since precast products are fully cured before they are delivered to the job site. This helps to extend work seasons in climates that may ordinarily restrict construction of conventional cast-in-place concrete projects. Precast concrete is non-toxic, environmentally safe, and made from all natural materials, making it an ideal material for use near natural waterways. For more information, please visit our website at precast.org.